Welcome to Unit 2, Module 8. Module 8 is about our new unit, the mole. The learning objectives for this module include converting the amounts of substances among moles, particles, and mass, learning to calculate the mass percent composition of a compound, and to determine the formulas for the empirical formulas and molecular formulas for compounds based on their mass percent composition. Before we get started, you will need to have out your periodic table as well as your calculator so that you can work out problems as we go. We will first begin by talking about formula mass. The learning objective for this section will include converting the amount of substances among moles, particles, and mass. So earlier we learned about atomic mass and how atomic mass was the average mass of a carbon atom or the average atomic mass of a hydrogen atom based on the abundance of all the different isotopes of carbon and hydrogen respectively. And so atomic mass is just the mass of one atom. Formula mass is the mass of a whole chemical formula for a molecule or for a formula unit if it's an ionic compound. So in order to find out the mass of this compound, we have to add up the atomic masses of all the individual atoms. And so the formula mass is equal to the sum of the number of atoms of each element times the mass of that element. And then we add that up. In your textbook, they use this symbol, which means sum of. And so whatever that symbol is in front of, that's what you're adding up. And so it's the sum of your number of atoms of one element times your atomic mass of that same element. These little subscripts down here, they're not a mathematical operation, they're just labels. So you're just adding up the sums of all these different things. So let's do a practice problem for this. And so this is where you'll need your calculator. So in this example problem, we're calculating the formula mass of copper 2-perchlorate hexahydrate. And so we can figure out which elements we have, how many of them there are. So I'm going to abbreviate quantity QTY for quantity, and then atomic mass of each. That way I can kind of organize my information before I begin. I see I have copper. I have 1 copper in that chemical formula, and so that is 63.55 AMU according to my periodic table. That decimal point's in a bad spot. I'll move that. And then I have chlorine. That 2 subscript distributes in, and so that means I have 2 chlorines. Each chlorine weighs 35.45 AMU on average. Oxygen, that's going to mean I have 8 oxygens from the CuClO4. And each oxygen is 15.999 AMU. And then from the 6 waters, that 6 distributes in. And so that means that I have 6 waters. Each water has 2. So that's a total of 12 hydrogens. That's 1.008 AMU. And then oxygen, again, that's going to be 6 oxygens. And that each oxygen is 15.999 AMU. And so then I can multiply these two columns to get a subtotal. And then I can add all the subtotals to get my overall formula mass. And so I'm going to work this out on my calculator. And so I have 1 times 63.55 plus 2 times 35.45 plus 8 times 15.999 plus 12 times 1.008 plus 6 times 15.999. And then I can hit enter. And so it tells me an answer, and then my calculator app is telling me another message too, but we'll just ignore that. So we'll come back over into the PowerPoint, and so the overall mass of everything is 370.532 AMU. As far as sig figs go, this should never be limiting your sig figs, but you can see here that when we're adding all these things up, all of these have at least 2 digits after the decimal point. And so your answer here should have at least 2 digits after the decimal point. If it does not, you need to have a better periodic table. So I'm going to say report to hundredths place at minimum. So don't worry about sig figs too much here. And I have the math worked out down below for I used a slightly different atomic mass of oxygen when I did this earlier. So depending on which periodic table you're looking at, when you calculate this, you might end up with slightly different values. And that's okay. We just recognize that. All right, so here's a practice problem for you. So go ahead and pause the video and try to work out the formula mass for each of the following compounds: calcium chloride, dinitrogen pentoxide, magnesium nitrate, and sulfur hexafluoride. All right, if you are watching now, you must be double checking your work. And so if we add up 1 calcium at 40.08 AMU plus 2 chlorines at 35.45, that will give us 40.08 plus 35.45 times 2, and so that should give you 110.98 AMU. And now I can do 2 nitrogens. Each nitrogen is 14.007 AMU, and 5 oxygens at 15.999 AMU, and so that is 2 times 14.007 plus 5 times 15.999, 108.009 AMU. For these next ones, we have to get our chemical formulas correct before we can calculate the mass. And so it's a good review of nomenclature. Magnesium has a common ion charge of 2+, and nitrate is NO3-. That means magnesium nitrate will need 2 nitrates in order to form a neutral ionic compound. And so now that I know how many of each element there are, I can set up my formula mass. 24.31 AMU plus 2 nitrogens at 14.007 each. And we got 6 oxygens. And so that's 24.31 plus 2 times 14.007 plus 6 times 15.999. And that's 148. Whoa. And then sulfur hexafluoride, that's a molecular compound, and so that's 1 sulfur and 6 fluorines. And so that's 32.06 AMU plus 6 times 18.998. So 32.06 plus 6 times 18.998. And that should be 146.048 AMU. And then we can go through the PowerPoint just to double check that I didn't do anything silly. And I think we're good. Again, your numbers may vary slightly depending on which periodic table you were referring to. That concludes our video for today. Continue to the next video to learn about the mole unit.